All right, let's get going. Oh, one thing I will say is some of the things you're going to see today, like this question, labeled pigs and chickens, goes all the way back to the beginning of the semester. And this one's about bicycles and tricycles, but same. The idea is the same. Some of the things you see might be like, wow, that was a long time ago. And what I'm hopeful of is that as we work through problems like this, you kind of recognize, oh, yeah, I remember how to do that. I get it. I got it. It's kind of it can be an important step to just kind of jog your memory a little bit. And that's part of the reason for the review, especially for things that are a little older as far as our semester goes, like this one. And I do want to mention, you won't see any polling today. We'll just kind of go through the problems, and we'll probably go through them a little bit faster than we did the very first time we saw them because it is review. But please don't take that to mean you can't ask questions. If you have questions, please feel free to ask them. Okay, here goes. We have a shop that has both bicycles and tricycles. When counting, we see that there are 32 bicycle seats and 32 seats and 72 wheels. And our question is, how many bicycles are there? Because this particular shop has both bicycles and tricycles, we want to figure out how many of them are actually bicycles. We're going to set up two equations here. One of them is going to be about the seats. And as far as the number of seats they have, a bicycle has one and a tricycle has one. So bicycles plus tricycles is 32. Essentially, what we're saying here is there are 32 cycles in the shop. The other equation we're going to set up is going to be about the wheels. There are 72 wheels. Well, a bicycle has two. So 2 times bicycle plus 3 wheels on every tricycle, and we add that together and get 72 total wheels. We have two variables and two equations, so we're going to be able to solve this. And our approach was to use what's called substitution. We looked at this equation up here at the top and said, if b plus t is 32, I can rewrite that to get one of the variables by itself. And let's just say I want to get t by itself. So I'm starting out with b plus t equals 32, and I'm going to subtract b from both sides. When I do that, those cancel, and t is going to be 32 minus b. This is where the substitution part comes in. Since t and 32 minus b are the same as each other, in the other equation, wherever I have a t, I can replace it with 32 minus b. So we'll do that. And we'll have, let's see, this second equation, I'll rewrite it as 2b plus 3. Instead of t, I'm going to put 32 minus b, and that equals 72. And now I'm going to solve. I have one variable, one equation I can solve. First thing is we'll distribute this 3 through the parentheses. So we'll have 2b plus 3 times 32, that's 96. And 3 times negative b is negative 3b, and that's going to equal 72. We're trying to solve this equation for b. We've got like terms here on the left-hand side, so we can combine those, the 2b and the negative 3b. So we'll go ahead and combine those, and we'll have negative 1b plus 96 is 72. I'm trying to get b by itself, so we'll subtract 96 from both sides. Those cancel, so that negative 1b is whatever 72 minus 96 is. 72 minus 96, negative 24. And then we can multiply both sides by negative 1, so that we wind up with positive 1b is positive 24. And so how many bicycles are there? Well, we just found out that b is 24. So how many bicycles are there? There are 24. You could also do this problem with trial and error. You could do it by drawing a picture. Make them all bicycles to start with, and then keep adding wheels until you get to 72, and then figure out how many bicycles you had at the end. That would work also. Here we have 24 bicycles. If there are 32 seats, be a little careful on this, because the question said how many bicycles are there, and that's what we found. But if this question had said how many tricycles are there, then we're not quite done yet. Then we can go back and say, well, If there's 32 altogether, and I know there are 24 bicycles, then we'll subtract 32 minus 24, and there must be 8 tricycles. Make sure you answer the question that you're asked. If you ask for bicycles, make sure you give that answer. If you ask for tricycles, make sure you give that one. Like I said earlier, let me know if you have questions as we go through any of these. Some of them are pretty old, might be a little rusty, but I'm hopeful that a little bit of a review sort of brings it all back into focus. Find the mean, median, and mode and range for the following data set. If necessary, round the mean to the nearest hundredth. Well, the first thing we were asked to find was the mean. And the mean is what we get when we add them all up and divide by how many there are. So our mean here is going to be 12 plus 19 plus 23 plus 10 plus 18 plus 33 divided by however many there are. 1, 2, 3, 4, 5, 6. So we'll add those up. 12 plus 19 plus 23 plus 10 plus 18 plus 33. That's 115 divided by 6. I get 19.166666. That keeps going. In this one, we were told to round the mean to the nearest hundredth. So I'll find the hundredths place, 2 past the decimal, look 1 space to the right. Since that number is 5 or bigger, we'll round this up to 19.17, and that's our mean. Up next, we're looking for the median. The median is the middle number, but be very careful. Before we find the median, we need to write these from least to greatest. So let's see, that'll be 10, 12, I'll do this, 18, 19, 23, 33. Okay, so there's my 6 data points written from least to greatest. I need the median, which is the one in the middle. If there were an odd number of data points, there'd be a median sitting right there, but there's not. There's an even number of data points. So what I do in that case is I find the 2 that are closest to the middle. Here, that's the 18 and the 19. I find the 2 that are closest to the middle, and it is the mean of these numbers will be the median of our data set. The median is a number that represents the middle of the data set. If there isn't a number sitting right there in the middle, we basically are finding what's in the middle of the 2 that are closest to the middle. Okay, so you could say what's halfway between 18 and 19, 18.5, and you'd be right. If you're more comfortable doing, I'm going to go ahead and find the mean of those, add them up and divide by 2. 37 over 2 is 18.5, and that's our median, 18.5. Mode, probably the easiest of these, whichever one occurs the most. 10, 12, 18, 19, 23, 33. None of these occur more than any other. When that happens, there is just no mode. If there is a data point that occurs more than the others, then it's the mode. Mode. And then finally, the range. The range is the highest minus the lowest. Kind of nice when we write these from least to greatest, that we can find the range by just taking a look there, and it'll be the largest data point, which is 33, minus the smallest data point, which is 10. So the range here is 23. So that's mean, median, mode, and range. Median is the only one that I would think might trip you up a little. Make sure you let me know if you have questions. All right. Something we looked at when we did our review for the final quiz, but we'll go ahead and revisit that again. In Connie's math class, homework counts for 10% of her grade. Quizzes count for 30%, and exams count for 60%. If her scores are as follows, what's her overall percentage in the class? And the first thing we have to do is find the homework mean, the quiz mean, and then the exam we don't really need to find a mean for because it's just kind of sitting right there. And so what we're going to do is we're going to add up those homework scores, 92 plus 0 plus 83 plus 76, and get 251 divided by 4. Be careful there. Make sure you divide by 4 because there are 4 scores. The 0 counts. We'll divide by 4 and get 62.75. We're not going to do any rounding until we get to the end. So keep all the decimals that you get for a number that is the mean of one of these categories. For quizzes, we'll do the same. We'll add the 94 plus 71 plus 97, and that's 262. And this time we're dividing by 3 because there's 3 scores. And that's 87.333, and that keeps going. We're going to keep all those decimals. So as many as our calculator will hold, that's what we'll type in when we go to find our overall grade. Now we're ready to do that. So our overall grade here, to find that, what we're going to do is we're going to take the homework mean and multiply it by the percentage of the grade that that counts for. So let's see, their overall grade is going to be the homework mean of 62.75 multiplied by 10%. And then the same thing with the quiz grade, 87.333 multiplied by, let's see, quizzes count for 30%. And then the exam mean, well, that's just 80. Oops, that's just 80, and we'll multiply by 60%. Okay, now we just need to multiply these. Let's see, 62.75 times 0.1, that's 6.275 plus, and I'll just do as many as my 87.333333, as many as my calculator will hold, multiplied by 0.3, and I get 26.2. And then 80 times 0.6 is 48. Finally, we just need to add these 3 numbers together to get her overall percentage in the class. And that's 80.475. We were told to round to the nearest hundredth, so we'll find the hundredths place, look to the right, that's 5 or bigger, so we'll round this up to 80.48. Don't do any rounding until you get to the end. And let me know if you have questions on this. This probably feels pretty familiar since we looked at it last time we were together. Okay. Counting problems. The fundamental principle of counting tells us to find the number of choices for each stage in the problem and multiply those together. That's what we're going to do here with this license plate. We have a license plate that is letter, 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 number, number, number. And we want to know how many of those are possible with repetition, and then we'll do it without repetition in just a minute. But if repetition is allowed, and we have letter, 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 number, 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 then let's see. There are 26 letters in the alphabet, and I don't have any restrictions here, so I can use all 26 letters in every one of those spots. This is the finding the number of choices for each stage in the problem part. For numbers, make sure you don't forget about 0. There's 1 through 9 plus 0, so there's 10 possible numbers for each space, and we'll multiply these together. Find the number of choices for each stage of the problem, and then multiply those together. 26 times 26 times 26 times 10 times 10 times 10, and that's, let's see, 17,576,000 license plates could be made with that structure. Doing this without repetition, what that means is once you've used a letter, you can't use it again. Once you've used a number, you can't use it again. We still have letter, 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 number, 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 but what changes here is the number of choices we have. For the first letter, we have all 26 to pick from. But now I've used a letter. I don't know what letter I've used, but I've used one of them. So I don't have all 26 to pick from anymore. I only have 25. Now I've used 2 letters. I don't know what those 2 letters are, but I can't use them anymore. So I only have 24 to pick from for this space. Same philosophy with the numbers. I have all 10 to pick from here, but then once I've used one, I can't use it again. So I only have 9 to pick from. Now I've used 2, so I only have 8 to pick from. Find a number of choices for each stage in the problem, multiply those together. 26 times 25 times 24 times 10 times 9 times 8. On that one, we get 11,232,000 possible license plates. The other thing I want to say about these is you might see instructions in there like the letter A, or excuse me, the letter I can't be used because it looks like a 1, so you can't use I. So if something like that were to happen, then you're starting with a baseline of 25 letters and going from there. If I and O can't be used, you're starting with a baseline of 24 letters because you've already eliminated 2 of them. And so keep that in mind for these types of problems. But the idea is find the number of choices for each stage and multiply those together. Permutations, and before, yes, it says permutations at the top, but I want to make sure you can identify this as a permutation. You have 7 dolls and we'll arrange 3 of them on a shelf. How many ways can this be done? A key here is, because we are going to arrange these on the shelf, if we arranged them as ABC, it would look different than CAB. If it would look different, if this is a situation where order matters, then we have a permutation. Arrange and order are key words to kind of help us out. But even if those words aren't there, if order matters, we have a permutation. And our formula for that, NPR, is n factorial over, n minus r factorial. If you have an NPR button on your calculator and you want to use it, you absolutely can. I'll go ahead and work through this one by hand. We have a total of 7, that's n, and we're using 3 of them in this problem, that's r. So it's 7p3. Now let's see, that's 7 factorial over 7 minus 3 factorial, or 7 factorial over 4 factorial. I'm going to rewrite 7 factorial as 7 times 6 times 5 times 4, 3, 2, 1. I stopped there because of the 4 factorial on the bottom. Those will cancel, and really this is just 7 times 6 times 5, which is 210. If you use the NPR button on your calculator and get 210, great, keep using it. If you're using the NPR button on your calculator and you're getting something other than 210, then I suggest doing it by hand instead because it's not really very much work. This one says combination at the top, which makes it obvious, but just a reminder, there are 9 players and 5 of them will be chosen to go in the game. How many ways can they be chosen? They're just being chosen to go in the game. They don't have positions. They're just going out. You're either on the field or you're not. The first person chosen and the 5th person chosen are the same. There's no difference. So here, order doesn't matter. And that's how we know we have a combination. Chosen is a word that lets us kind of point towards combination. Select, pick, those are words that point us towards combination because we're not putting anything in a certain order. We're just choosing it. We have a formula for combination. NCR is n factorial over r factorial and minus r factorial. And in this case, we have, let's see, 9 total players, and we're putting 5 of them in the game. So it's 9 choose 5, combination of 9 things taken 5 at a time. Again, if you have an NCR button and you want to use it, that's totally fine. By hand, this will be 9 factorial over 5 factorial, 9 minus 5 factorial, or 9 factorial over 5 factorial, 4 factorial. We're not going to make that 20 factorial on the bottom. That introduces a whole mess of numbers that we don't want. Instead, I'm going to rewrite 9 factorial as 9, 8, 7, 6, 5 factorial. And I stop there because that's the larger of the 2 numbers on the bottom, and I'm going to cancel it. I'm also going to have 4, 3, 2, 1 on the bottom. Those 5 factorials are going to cancel each other out. And now I have 9 times 8 times 7 times 6 on top, which is 3024. 4 times 3 times 2 times 1 on the bottom, which is 24. I'll divide those and get that there are 126 different ways that these players could be sent into the game. I don't usually find very many who like it, but one thing you can do when you get to this point is you can do more canceling. Dividing by 1 won't do anything, and 4 times 2 will get rid of the 8, and 3 will go into 9 3 times, and that leaves you with 3 times 7 times 6, and that gets you to 126. If you don't like that, that's okay. If you want to use an NCR button, that's okay too. Tree diagrams, probably the most challenging thing that we did when we were studying probability. You may agree or disagree, but for a lot of students, this is the most challenging thing with probability. A gumball machine contains 5 green and 4 white gumballs. You're going to buy 2, and they're gumballs, so it happens one after the other. Find the probability of getting 1 green and 1 white, at least 1 white, and that the second one is green. We're going to make a tree diagram for this because we're not after a single specific outcome. And when I do that, let's see. When I buy the first one, it's either going to be green or white, and there'll be probabilities that go with that. Let's see, there's 9 total. So the probability of green is 5 out of 9. Probability of white is 4 out of 9. Probability is successes over outcomes. I have 9 total outcomes here. 5 are green, so that probability is 5 ninths. 4 white, so that probability is 4 ninths. Again, don't hesitate to ask questions if you have them, especially on something like this. It's not that long ago that we studied it, but it can be a challenging concept. I'm going to buy a second one that's either going to be green or white, and I need those probabilities. Let's see. If I'm up here, that means that the first one I bought was green. So I'm going to take that into account when I put my probabilities on. I only have 8 gumballs left. I started with 5 green. I bought a green, so I only have 4 greens still in there. So the probability of green is 4 out of 8. I started with 9 altogether, so there's 8 left. I started with 4 white. I bought a green, so there's 4 white still in there. So the probability of white is 4 out of 8. Now we're going to finish off the bottom of our tree down here where the second one can be green or white. And this time, because we're down here at the bottom, that means the first one we bought was white. And we're going to keep that in mind when we put our probabilities on. There's 8 gumballs left. I started with 5 greens. I bought a white one, so all 5 greens are still in there. There's 8 gumballs left. And I started with 4 white. I bought a white, so now there's only 3 white ones left. Now I've made my tree diagram. I've put my probabilities on. Now I'm ready to go create my sample space. And I'm going to create that sample space by multiplying along the probabilities. Green followed by green, 5 ninths times 4 eighths. I'm going to multiply those probabilities. 5 times 4 is 20. Over 9 times 8 is 72. So the probability that I get green followed by green is 20 out of 72. In the second one, that'll be green followed by white. 5 ninths times 4 eighths. So let's see. 5 times 4, that's 20. 9 times 8 is 72. That's the probability of getting green followed by white. Continuing right down our tree, we'll have white followed by green. 4 ninths times 5 eighths. 4 times 5 is 20. 9 times 8 is 72. And that's the probability of white followed by green. And then finally, not a very interesting list of probabilities so far, but the last one will change it up a little. White followed by white will be 4 ninths times 3 eighths. 4 times 3 will be 12 out of 72, and that's the probability of white followed by white. At this point, we have our sample space. So we're done with the tree. We're done multiplying. If there's more than one way to have a success, we might have to add some of these probabilities together, but we're all done with multiplication once we get to here. The first question we were asked said, what is the probability of getting 1 green and 1 white? So we have to go find outcomes that have that. Well, this is 2 greens, so that's no good. Green, white, yep, that's 1 green and 1 white. White, green, yep, that's 1 of each. And white, white is no good. So I have 2 ways that I could have a success here. I could get one green and one white this way, or I could get one green and one white this way. And since there's more than one way to have a success, we'll add those together. When we add those fractions, we just add the numerators. 20 plus 20 is 40. Denominator stays the same, 72. So the probability of getting one green and one white is 40 out of 72. There's more than one way to have a success. We need to add those probabilities together. I lost half of my W there. I need to put it back in, or my G. I need to put it back in. There. Okay. The second question we're given is, what is the probability of getting at least one white? So if there's at least one white, that's a success. Well, here's green, green. No, green, white, white, green, white, white. At least one. So one or more. So white, white counts here. So now I need to add these three probabilities together. And that'll be 20 plus 20 is 40. Plus 12 is 52 out of 72. Just a little bit of a reminder that probabilities can be written as decimals or fractions. And so I want to make sure you're comfortable writing them both ways. Let's say like this one here, this 52 out of 72. If we were supposed to write that as a decimal rounded to the nearest hundredth, we just divide 52 divided by 72. When I do that, I get 0.7222. And if we were supposed to round it to the nearest hundredth, find the hundredths place, look one space to the right. That's 4 or lower, so we would round this down to 0.72. Just one extra step if you need to write it as a decimal, and that's make sure you divide. Last one that we're given here is, what's the probability that the second gumball is green? Well, now I just look for, where's the second gumball? This is green, green, so yes, that's a success. Green, white, there's a green in there, but not the second one. White, green, yes, the second one was green. White, white, no. So I have these two successes. I could have a success this way or this way. I'll add those together and end up with 40 out of 72 for the probability that the second one is green. Just a coincidence that these happen to be the same as each other. Don't read anything into that. If that's comfortable for you, that's awesome. Expected value. Expected value is what happens over the long run. And here we have a jar that contains 3 yellow, 4 white, and 11 red marbles. If you reach in and pull one out, if you pull out a yellow, you win $4. If you pull out a white, you lose $1. And if you pull out a red, you lose $3. Rounded to the nearest hundredths, what's the expected value of picking a marble? When we see an expected value question, what we're going to set up is, what are the possible results and what are the probabilities that go with them? So here our results are, well, I could win 4, lose 1, or lose 3. And the probabilities that go with those, well, to win 4, I'd have to pick a yellow marble. I can see that there are 3 successes. I need to figure out how many outcomes there are. Let's see, 3 and 4 is 7 and 11, so that's 18 total. Jot that down, that's pretty useful. 18 total marbles in the jar. All right, so the probability of picking a yellow and winning $4 is 3 out of 18. The probability of losing $1, which means I picked a white marble out, is 4 out of 18. And the probability of losing $3, which means I picked a red marble, is 11 out of 18. Now that I have my results and probabilities, I'm ready to calculate expected value. 3/18 of the time, a player is going to win $4. 4/18 of the time, the player is going to lose $1. And then 11/18 of the time, the player is going to lose $3. We just need to simplify, and we'll have our expected value. One thing that you might want to do here, you don't have to, is rewrite these whole numbers as fractions. You don't need to do that, but if it helps you, by all means, go ahead. And now we're going to multiply. Numerator, 3 times 4 is 12, 18 times 1 on the bottom. 4 times -1, make sure you bring the negative, 18 times 1. 11 times -3 is -33. 18 times 1 is 18. Now we add them. We already have a common denominator, so we just need to add those numerators together and we'll get something over 18. Let's see, 12 minus 4 minus 33, that's negative 25 over 18. We'll go ahead and divide that. Expected value answers will be a decimal, and I get negative 1.38888. That keeps going. For this one, I was told to round to the nearest hundredth. So we'll find the hundreds place, look one space to the right. That's 5 or bigger, so we'll round this up to negative 1.39. Expected value for somebody who plays this game is they would expect to lose $1.39 per play. Another concept that can be a little challenging sometimes, so don't hesitate to let me know if you have questions. Binomial probability. This is one where we used Pascal's triangle. And if you need Pascal's triangle, it will be given to you on the exam. You don't need to write down Pascal's triangle. And the way we use this is for binomial probabilities, things with two outcomes. What Pascal's triangle does is it lets us know how many ways each outcome can be achieved. A family wants to have 4 children, find the probability that they get at least one girl. Since they're going to have 4 children, we have 4 outcomes here. That means we go look at row 4. And when I look at row 4, what I see there is 1, 4, 6, 4, 1. I'm going to put some labels on here because when you have children, it's boy or girl. And the most possible girls you could have would be 4 girls. And so there's only one way you could do that. Girl, 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 girl. That's it. That's the only way. But there are 4 ways that you could have 3 girls. There's 6 different ways you could have 2 girls. There's 4 ways that you could have 1 girl. And there's only one way you could have no girls. That's all boys. You don't have to put the boy labels on there too, but I like to, just to sort of, depending on what question I'm asked, this really fills in all the gaps for me. Make sure I have all the information I need. 4 girls would mean no boys. 3 girls is 1 boy, 2 boys, 3 boys, and 4 boys. Okay, and that's all the ways that I could do these things. Keeping in mind, what we're after here is a probability question. And probability is successes over outcomes. The total number of outcomes is what I get when I add all of these together. 1 plus 4 plus 6 plus 4 plus 1. So 1 plus 4 plus 6 plus 4 plus 1, that's 16. So there are 16 total outcomes here. That's going to go on the bottom of my fraction. And then I just need my successes. Probability of at least 1 girl. So I want to find all the outcomes that have at least 1 girl. Well, this is no girl, so that's no good. 1 girl, yep. 2 girls, yeah, that's at least 1. 3 girls, yeah, that's at least 1. 4 girls, yeah, that's at least 1. So I could have at least 1 girl this way, or this way, or this way, or this way. So I'll add those together. Same thing we did when there was more than one way to have a success in our tree diagram. I'll add that together, 1 plus 4 plus 6 plus 4, and get 15. So the probability of getting at least 1 girl is 15 out of 16. Don't forget about the denominator here. It's easy to kind of get locked into the 1, 4, 6, 4, 1, and then finding your successes and writing down 15, which is great. But remember, all probabilities are between 0 and 1. So 15 can't be correct. Don't forget about the outcomes that needs to go on the bottom. And that's what you get when you add all of those together. On to some geometry. Quadrilateral relationships. These are true-false type questions where what we're going to do is see if we can find a counterexample. If we can find a counterexample, then we can say it's false. In the effort to try to find a counterexample, we might convince ourselves that the statement's true, and that's good enough. You're not going to have to do any kind of a proof. So let's take a look. All rectangles are parallelograms. So what I'm going to try to do here is draw a rectangle that's not a parallelogram. Let's see if I can. Well, I draw a rectangle, and Well, to be a parallelogram, top and bottom and left and right, yeah, two pairs of parallel sides. Yeah, that rectangle's a parallelogram. Okay, well, what if I draw my rectangle tall and skinny? Yeah, left and right are parallel, top and bottom are parallel. You know what? Every time I draw a rectangle, it's going to have two pairs of parallel sides. So every time I draw a rectangle, it's going to be a parallelogram. So that one's true. True false questions on the surface feel like they should be easy, but it turns out that they're not. I find these to be kind of challenging. Maybe you don't, and if not, that's great, but I think they kind of are. Every rhombus is a rectangle. So every rhombus is a rectangle. I'm going to try to draw a rhombus that's not a rectangle. There's a rhombus. Hey, wait, that doesn't have 90-degree angles. Right there is my counterexample. This is a rhombus that is not a rectangle. So if you're trying to tell me every rhombus is a rectangle, that's false, and here's my evidence. All right, sounds like we're doing pretty good. Let's do the same thing with triangles. Every isosceles triangle is equilateral. Same idea. I'm going to try to draw an isosceles triangle that's not equilateral. Well, an isosceles triangle has two sides the same length, or at least two sides the same length. That one has two sides the same length, at least two sides the same length. That qualifies as isosceles, but I can tell it's not equilateral. The bottom is not the same length as the two sides. So every isosceles triangle is equilateral? Well, no, that's false, because right here is my counterexample. The one at the bottom. All acute triangles are right triangles. One of the things I want to emphasize here is you have to make sure you know what isosceles and equilateral mean. You have to make sure you know what acute and right mean in order to answer these. So make sure you spend a little time with the definitions. Acute, all the angles are less than 90. So, if I just draw a triangle like that, that's an acute triangle. All the angles are less than 90. This is supposed to be a right triangle? All acute triangles are right? Well, no, here's one that's not. So that's false. In fact, an acute triangle can't be a right triangle. So that one was definitely going to be false. Now let's talk a little bit about our transformations. A reflection. If we want to reflect the given figure across the horizontal line. So I have this R, and I want to reflect it across the horizontal line. I'm going to get a mirror image over here. And if you're really good visually, you can do it that way. Another way is you kind of put on your paper, well, I'm going to take some key points on here, and I'm going to go perpendicular to the line of reflection and go the same distance away, and that's where that point's going to end up. A key point over here, perpendicular to the line of reflection, same distance away, perpendicular, same distance, and now I have enough to draw my picture. Same thing's true for the vertical line. Some of you may be able to look at this and say, well, if I'm going to reflect that vertically, it's just going to look like this. But you may want to put on your paper, well, wait a minute then. This is a hard one, this vertical. So I'm going to go perpendicular to the line, same distance away. That's the bottom left side of the R. And perpendicular to line, same distance away, that's the other bottom. And if I do this key point and go perpendicular, same distance, and maybe at that point you have enough to draw it in. If not, go ahead and find another key point, maybe over here on the tip of the R, perpendicular to the line, same distance away to draw it in. But that's a reflection, mirror image. It'll always have a line of reflection. A rotation. Determine the rotation of triangle ABC if it is rotated 90 degrees clockwise about point C. So we're going to have a center of rotation. Here that's point C, and that point is not going to move. Everything's going to move except for that point. So that point's going to stay fixed, and now we look at our instructions here to rotate this triangle, and we're going to rotate 90 degrees clockwise. First thing we have to think is, okay, clockwise is that way. So what that means is when I rotate this whole thing's going to move in that direction. Okay, with that in mind, 90 degrees, that's kind of one of the rotations that we focused on because it keeps things relatively simple. it means a vertical line is going to become horizontal. So this line that goes from C to A is now going to go over here to A prime. I've moved it. I've rotated it 90 degrees clockwise. And then this horizontal line that goes from A to B down there, now that's going to become vertical, and B prime is going to be here. I can just draw in the diagonal, and there's my triangle rotated 90 degrees clockwise about point C. Transformations. Identify the transformation that maps the green pre-image to the purple image. So if we're starting with the green, how do we get to the purple? And if we look at these, what I'm hoping that you see is, well, to get this green one to go down here, excuse me, what I'm going to have to do is a rotation wouldn't work, because if I did a rotation, it would be this way, and that's no good. So instead, we're going to do a reflection across a horizontal line. That's how we would get there. Basically, practice makes these easier, and I hope you're in a place where you feel pretty comfortable with them. If you're not, it's absolutely fine to ask. Map the green pre-image to the purple image. This one is going to be a rotation going counterclockwise. This one's a little odd because the center of rotation would be down there. That's the thing that doesn't move. Like if we were to have that on a piece of paper and put our finger where the dot is and turn it, that's how we would get there. So we don't have to give the angle of rotation here. We just have to be able to identify a rotation. And then this one over here, the green pre-image to the purple image, we're just going to slide this down and to the left. So that's going to be a translation. Symmetry. I really like using flags to identify symmetry. I think it's a great way to sort of have a shape that's pretty recognizable, where we can look for either vertical line symmetry, horizontal line symmetry, and rotation symmetry. And let's just see what we've got here. Vertical line. If I put a vertical line in here, do I get a mirror image? Yes, I sure do. So this does have vertical line symmetry. If I were to draw a horizontal line, oh, wow. How about, yeah, you know what? That is going to work. If I put a horizontal line right through the middle and I fold this, sure enough, horizontal line symmetry works. It's going to land right on itself. I won't be able to distinguish my reflection from the original. And then a rotation symmetry here, well, obviously rotating 90 degrees isn't going to work because the flag will be oriented the wrong way. But if I rotate this 180 degrees, so that, you know, this corner goes 180 degrees over to that corner, then, or if you prefer, take your paper and just kind of turn it upside down. Oh, you know what? It is exactly the same. So this one has rotation symmetry at 180 degrees. This one happened to have all three symmetries: vertical line, horizontal line, and rotation at 180 degrees. Not all images will. This one did, and it's probably a good example for me to do so you can see a case where this is what vertical line symmetry looks like, this is what horizontal line symmetry looks like, and this is what rotation symmetry looks like. Similar triangles. If we're told that those two triangles are similar and we're asked to find DE, the way we're going to do that is with a proportion. And now we're getting into stuff that's more recent, so it's probably more fresh in your head and probably very comfortable. At least that's my hope. If I want to find DE, well, DE is this line right here. So the one that corresponds is AB. So I need to keep that in mind when I go to set up my proportion. Although it's really important that I find a relationship between those triangles. And the only thing I know in triangle DEF is this 8-foot side down here. Over in triangle ABC, the corresponding part is this 12-foot side. So I can set up the ratio of those, 12 to 8. And so I have my triangle on the left on top, my triangle on the right on the bottom, 12 over 8. Looking at the thing I'm trying to find, I've got this 15 here, and DE is the thing I don't know. I'll just call it X. You could call it DE if you want to. So let's see, 12 is to 8 as 15 is to x. So that's the proportion that I'm going to set up. 12 is to 8 as 15 is to x. Now I just need to solve this proportion. And I'll have 15 times 8 is 120. 12 times x is 12x. And then to get x by itself, we'll just divide both sides by 12. Those cancel, leaving me x. 120 divided by 12 is just 10. This said round to the nearest tenth. Well, there isn't any rounding to do here. It's just 10. Something else that we talked about in preparation for the final quiz, so this will probably feel pretty fresh, is dimensional analysis. If we're supposed to convert 2 quarts to milliliters, and the way that I kind of like to phrase these questions is use the fact that 1 liter equals 1.057 quarts, and that 1,000 milliliters equals 1 liter, convert 2 quarts to milliliters. And so that's what we'll do. And how to start these types of problems is sometimes the hardest thing, but 2 quarts is what we're trying to convert. So that's what we start with when we set up our scaffolding. And now I need to get away from quarts. I don't want to have quarts anymore. So I'll find the unit fraction that I've been given that has quarts in it, and it's that one. Because I want quarts to cancel, I'm going to put my 1.057 quarts on the bottom and my 1 liter on the top. And that's progress. That's good. I'm trying to turn quarts into milliliters. I'm not there yet, but I'm on the way, because now these quarts cancel and what I have is liters. Now I need to convert these liters into milliliters, and I have another unit fraction that I'll use. I'll put my 1 liter on the bottom because I want those to cancel. My 1,000 milliliters on the top. Now my liters cancel, and I can see that the only units I have left are milliliters, which is what I was trying to get to. So now I'll multiply everything on the top, multiply everything on the bottom. And when I do that, let's see, on the top I have 2 times 1 times 1,000, so that's 2,000, and that's milliliters. On the bottom, I have 1.057 times 1, and I don't have any units. And the last thing I'll do is divide. 2,000 divided by 1.057, and I get 1,892.1475. That keeps going. But I was told to round here, so I don't have to keep all of them. I'm going to round to the 10th place, right next to the decimal. Look 1 space to the right, that's 4 lower. So we'll round this down to 1,892.1 milliliters. Your answer would just be the number. Again, that's one we worked on last week, so it's probably fairly fresh. Percent error. Percent error is driven by a formula. And we see a question like a 30-foot tall tree is measured to be 25 feet tall. What's the percent error? And that formula for percent error is the amount of error divided by the actual amount. And so in this case, you could probably skip the step I'm going to do first, but our percent error, there's going to be the amount of error. So the tree is actually 30 feet tall. It's measured to be 25. I want the difference between the actual measurement, or excuse me, yeah, the actual measurement and what it was measured to be. I want the difference between those, so we're going to subtract. That's the part you might be able to skip. You might be to say, well, it's off by 5, and just throw a 5 in the numerator. Totally fine if you do it that way. On the bottom, this is where you have to be careful. Make sure you use the actual amount. Let's see, it's measured to be 25, but it's actually a 30-foot tall tree, so 30 is what needs to go in the denominator here. And so we'll have 5 over 30. And that's 0.166666. That keeps going. We were asked for percent error here. What is the percent error? That's what this question is about. So instead of a decimal answer, we want a percent answer. So we're going to move the decimal 2 places and have 16.66666%. This one didn't tell us how to round. Out of nowhere, I'm just going to make it up. We'll round to the nearest hundredth. And so we'll find the hundredths place. Look one space to the right. That's 5 or bigger. So we would say the percent error is 16.67%. Instructions on the exam would tell you to not use a percent symbol. So don't. And basically that's because you have to decide whether to put a space in or not, and then Canvas has to decide whether that's okay or not. And so 16.67 is all you need. Perimeter and area. Let's talk about a triangle. A right triangle has a hypotenuse with a length of 17 feet, and one leg has a length of 15 feet. What is the perimeter of this triangle? We have to remember perimeter is the distance around. And let's see, I'm told that I have a right triangle. So there's my right triangle, has a hypotenuse. Have to remember that word. That's the longest side. That's 17. And one of the legs is 15. And what I'm after here is the perimeter. To find the perimeter, I imagine myself standing at a corner and walking all the way around the figure. But I can't find the perimeter until I know this third side length. This is the type of question that I enjoy because in order to find the perimeter, we're going to have to use Pythagorean theorem. We've got a right triangle. We're going to have to do leg squared plus leg squared is hypotenuse squared. That's going to help us find this side length over here, and then we can find the perimeter. So this is the thing I don't know. I'll go ahead and call it X. You could call it L for leg if you wanted to. And we have leg squared plus leg squared is hypotenuse squared. So X squared plus 225 is 17 times 17, 289. I'm trying to get X by itself. So I'm going to subtract 225 from both sides. Those cancel, and I have X squared is 64. Now I want squared to go away. In order to make squared go away, I'm going to take the square to the left because square root and squared will cancel each other out. But if I take the square to the left, I also take the square to the right, and I get X is the square root of 64, which is 8. Boy, is there a strong pull to be like, great, answer is 8, I'm moving on. But remember, all we've done here is figure out that that was 8. We still need the perimeter of this triangle, so we have more work to do. We have to go back and just, it's not a ton more work, we just have to add up these 3 side lengths to get the perimeter. 17 plus 15 plus 8, which is 40. They would be feet, but you could just respond with 40. Now we're getting really recent. Arc length. A circle has a radius of 3 inches. Rounded to the nearest hundredth, how long is the arc that is cut by a 65-degree angle? You don't have to draw a picture of this, but sometimes it helps me just kind of orient myself. I've got this circle here, and it has a radius of 3 inches. How long is an arc that's cut by a 65-degree angle? So if I were to kind of just ballpark a 65-degree angle on here, what we're after when we're asked for the arc length is this little chunk of the circle right there. How long is it? That's what an arc length is. So that's what we're trying to find. And what we're going to do is we're going to use a proportion. The first thing I'm going to do is find the circumference of the circle. How far is it all the way around? And the circumference is 2 times pi times the radius. So here that's going to be 2 times 3.14 times the radius of 3. And let's see, that's 2 times 3.14 times 3 is 18.84. And there'll be inches, but the 18.84 is the important part for us. What we just found out is all the way around the circle is 18.84, and that corresponds to 360 degrees. What we want to know is how far would you go if you only went 65 degrees? So we set up a proportion for that. that 18.84 is how far you'd go if you went 360 degrees. How far would you go if you only went 65 degrees? Now we have a proportion that we can solve. X times 360 is just 360x. 18.84 times 65 is 1224.6. Then we'll divide both sides by 360. We only have an x on the left, and I get 3.40166. Here I was told to round to the nearest hundredth. So we'll find the hundredths place, look one space to the right. That's 4 or lower. So we'll round this down to 3.40 or just 3.4. That would be fine also. If Canvas doesn't give you credit, you just send me an email and tell me that you should get credit. Basically what we're saying is if it's 18.84 all the way around, then this piece right here has a length of 3.4. Surface area and volume of a box. These were both driven by formulas. Volume of a box was just length times width times height. And surface area of a box was a little more involved. It was 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Essentially, we're looking at the area of the top and bottom, the front and back, the left and right. This question says, find the surface area and volume of a box with a length of 8, a width of 3, and a height of 2. Essentially, this is about using these two formulas. I put volume on the left, so we'll go ahead and do it first. The volume here is going to be the length times the width times the height. 8 times 3 times 2, 24 times 2 is 48. Since this is inches, they would be cubic inches because it's volume, how much space will fit in there, but our answer is just the 48. And then for surface area, this is a little longer. Let's see, that's 2 times length times width plus 2 times length times height plus 2 times width times height. Be careful when you plug these in. These are very straightforward questions, and the arithmetic that we have to do now is not difficult, but it's really easy to make a mistake when you plug in. So maybe do the plugging in part twice just to make sure that you have it. And let's see here. So we have 2 times 8 times 3 is 48 plus 2 times 8 times 2, which is 32, plus 2 times 3 times 2, which is 12, and then we'll add all those together. And we get a surface area of 92. This would be square inches because we're talking about area, but your answer would just be the 92. Remember that you are allowed to have one page front and back of notes, so it's perfectly fine for you to have these formulas written down. Something you've seen before, and this you probably, if you had me for 122, this will be the 6th time that you've seen it, but here we go. When you take this exam, I want you to be realistic and positive. Do not be a perfectionist. Do not be negative. Perfectionist says there's an impossible amount of things to learn for this test. Well, that's not true. We just talked about the main ideas that I want to make sure you're comfortable and confident with in a relatively short period of time. And the realist says, well, I don't need to know every question to pass. That's absolutely true. You can get a really good grade without getting every question right. And you can absolutely pass without getting every question right. My knowledge of a certain topic is shaky. Kind of depends on when your appointment is, but if you start studying now to fill in those gaps, obviously if everything we did today seemed really challenging, that's a tough place to be. But if there's one or two things that you need to go back and practice a little more, hopefully you have time to do that. I always do poorly on tests. Always is a big word. I bet we can find a counterexample. I bet there's a quiz in this class that you've done well on, or maybe one of the first two exams. So that's probably just not true. And perhaps you have struggled a little, but maybe for this one, you're more prepared than you felt on the others. If I don't pass this test, I'm a failure. Please remember, this is one test in one class in one semester of college. There are a whole lot of other aspects to your life and about you that define you, not this exam, not this class. So please don't feel that way. Here's one that we can't really count today. If I'm gonna pass, but if I don't, I can bounce back. That one we can't really do today because this is it. This is our last exam. I want you to be well prepared and do a really good job. If you're on the borderline between a couple of grades, really put in the effort on this one so that you get yourself bumped up a level rather than falling down a level. This test is going to have a trick question. It absolutely will not on purpose. The very first one we looked at today, bicycles and tricycles. If you find the answer for bicycles, but the question asks for tricycles, please make sure that you're careful about how you respond. If a question asks for the perimeter of a right triangle and you go through all the work to find the side length, make sure you answer the questions being asked. If it asks for perimeter, take that extra step to find perimeter. I won't have a trick question on purpose. And then this test is designed to let me show what I know. Maybe you struggled with something on the quizzes. Maybe you struggled with something on the first or second exam. If that's true, this is a chance for you to say, you know, I had a tough time with this before, but now I've got it. And this is a chance for you to prove that. And so I just